China built a 60,000-seat stadium shaped like a Song Dynasty ship hull, with passive cooling, wetland flood management, and a roofline that looks like it came from the future in under 2 years. America's SoFi Stadium took 6 years and $5.5 billion. You heard that right, $5.5 billion. That is more than the GDP of some small nations. And what it bought was a covered concrete bowl that hosts football roughly 8 times a year. And that is just the beginning. Because the craziest part is not the cost. It is not even the timeline. It is the fact that the gap between these two buildings is not an engineering gap, or a money gap, or a talent gap. It is something much harder to fix than any of those things. And to understand what that something actually is, you need to start with the buildings themselves. 2 stadiums, 2 civilizations. Picture 2 buildings, both called stadiums, both capable of holding tens of thousands of people, both built within the last decade by wealthy, technologically advanced societies. And yet, standing inside one of them feels like standing inside the future, while standing inside the other feels like standing inside a parking structure that someone forgot to finish. The Greater Bay Area Sports Center in Guangzhou does not look like a sports venue. It looks like a civilization decided to leave a message. The roof curves in the shape of a Song Dynasty ship hull not as decoration, but as a structural decision that channels wind, manages heat, and integrates a wetland system underneath that handles stormwater flooding. The building thinks. It responds to its environment. It was conceived not as a revenue asset for a private franchise, but as a civic gift to an entire region, and it was delivered in under 2 years. Now here is the part that puts everything into perspective. SoFi Stadium in Los Angeles, which opened in 2020, cost $5.5 billion. That is roughly the same as building 4 aircraft carriers. You heard that right. For the price of 4 warships, Los Angeles got a concrete bowl with a roof. It took 6 years to complete. It required over 20,000 pages of environmental documentation. 20,000 pages. That is longer than the entire works of Charles Dickens, twice over just to get permission to break ground. Here is what most people get wrong about this comparison. They assume China simply spent more, or cut corners, or skipped the rules. None of that is true. The Greater Bay Area Sports Center was not cheaper because it was simpler. It was cheaper because the system around it was built for speed. The approval moved fast. The financing was direct. The workforce mobilized immediately. The architecture was never subordinated to a revenue spreadsheet. That last point matters more than any of the others. SoFi was not designed to be beautiful. It was designed to be profitable. Every structural decision was filtered through what sponsors would pay for, what suites could be sold, what naming rights would justify. The building you see at the end of that process is not what the architects imagined. It is what the financial model permitted. And that is the civilizational gap hiding inside these 2 buildings. One society asks, what do we want to build? The other asks, what can we afford to let through? One system starts with ambition and works backward to logistics. The other starts with liability and works backward to architecture. The results speak for themselves in steel and glass and concrete for anyone willing to look directly at them. Both stadiums are real. Both are finished. Both will stand for decades, but only one of them will make the people inside it feel like they are living in a remarkable moment in human history. And the gap only gets wider from here, because the stadiums you have not seen yet make SoFi look modest by comparison. The impossible buildings. Let's walk through the buildings themselves, not as a list of impressive facts, but as a challenge. Because once you see what China has actually built, the question stops being, how did they do that? And starts being something more uncomfortable. The question becomes, why hasn't anyone else even tried? Start with the Hangzhou Olympic Sports Centre. The roof is made of 28 individual steel petals, each one parametrically engineered, each one a slightly different shape, each one load-sharing with the others, so that the entire structure uses 67% less steel than a conventional stadium roof. Think of it like a cathedral arch. The strength comes from the geometry, not the material. Remove one piece and the whole system redistributes. It is not just beautiful, it is structurally genius. Now look at MetLife Stadium in New Jersey. Exposed steel frame, optimized for maintenance access. Looks exactly like what it is, a building designed by an insurance assessment. Here is what makes this incredibly exciting. The Chengdu Fenghuangshan Stadium took that logic and pushed it into territory that sounds like science fiction. Its retractable roof runs on magnetic levitation, tracks the same technology that powers China's bullet train network. No friction, no mechanical wear. 77,000 individually programmable aluminum panels wrap the exterior, turning the entire building into a programmable lantern after dark. Every panel can change. The building is not static. It performs. Compare that to Allegiant Stadium in Las Vegas, whose defining innovation is keeping the desert heat outside. That is the ambition. Thermal management. Now here is the part that blows people's minds. The Kai Tak Stadium in Hong Kong is built on 800 seabed piles driven directly into the harbor bed. Its retractable roof weighs 4,800 tons and closes in under 30 minutes against typhoon-force winds. The same footprint contains a metro station, a shopping complex, and a waterfront public park, all integrated, all functioning, all open. Levi's Stadium in Santa Clara took 8 years of planning disputes to deliver a conventional bowl with a grass roof that struggles to drain properly in California rain. Then there is the Dalian Suoyuwan Stadium, surrounded by sea on 3 sides, built on reclaimed industrial land, engineered to marine oil rig standards, to survive salt spray and sustain typhoon conditions. Its facade mimics ocean waves in ETFE, the same material used in high-performance greenhouse architecture. And wrapping the entire structure is a 1-mile double-helix public ramp spiraling to a rooftop panoramic view of the bay. Free, every day, open to anyone. Most American stadiums charge for parking. And sitting above all of them is the bird's nest. 42,000 tons of interwoven steel, where the structure and the facade are a single, inseparable system. Engineered to survive major earthquakes, with 91,000 people inside, built at the absolute frontier of computational structural analysis. But extraordinary buildings do not explain themselves. To understand why China can build these, and America cannot, you need to go one layer deeper into the system that either allows a building to exist or quietly kills it before it ever begins. The approval trap. Before a single steel beam is lifted into place, on an American stadium project, the project is already losing. Not to a competitor, not to a budget crisis, to a system. A legal, environmental, and bureaucratic architecture so dense, so layered, so deliberately slow that by the time a building gets permission to exist, the original vision has usually been negotiated into something unrecognizable. Here is how it works. A developer proposes a new stadium. Immediately, the environmental review process begins. In California, under the California Environmental Quality Act, that review can take years. Thousands of pages of documentation must be produced, reviewed, contested, revised, and resubmitted. SoFi Stadium required over 20,000 pages of environmental documentation before a single shovel touched the ground. To put that in human terms, 20,000 pages is roughly equivalent to reading the entire Bible 30 times in a row just to get permission to build. Now here is the brutal catch. Environmental review is only one layer. After that comes zoning approval, which can trigger community opposition hearings. Then financing approval, which requires satisfying multiple private lenders with competing risk assessments. Then union labor agreements, which affect scheduling and sequencing. Then independent structural code certification for any novel engineering approach, which, in practice, means anything that hasn't been built before in America needs years of testing and legal sign-off before it can be legally installed. Each layer adds time. Each layer adds cost. And here is the detail that engineers don't want to admit. Each layer also adds conservatism, because at every approval gate, the path of least resistance is to simplify, to use a structural system that has been approved before, to choose a facade material that has existing code coverage, to remove the parametric pedal roof and replace it with exposed steel because the insurance underwriters understand exposed steel and don't understand anything else. China's state planning model does not move through these layers sequentially. It moves through them simultaneously, or it bypasses them entirely through central coordination. A 70-hectare sports complex can be approved, funded, and broken ground upon in months. Not because China ignores consequences, but because the system is architecturally designed to build, while America's system is architecturally designed to review. The result is not just slower buildings, it is architecturally diminished buildings. Because every month of additional review is another month for financial pressure to accumulate, for political opposition to organize, and for the original design to be traded away in exchange for approvals. By the time SoFi Stadium was approved, the architects had already lost most of the fights that mattered. The building that opened in 2020 was not the building they imagined. It was the building the system permitted. And the approval process is only one of the walls. Because even if you somehow navigate every legal layer intact, you then walk directly into a problem that no amount of patience can solve. Who pays and what they want. Every building tells you who paid for it. You just have to know how to read it. Look at the luxury suites stacked along the side of an American stadium, and you are looking at the financing structure made physical. Look at the sponsor name bolted to the exterior, and you are looking at the revenue model expressed in steel letters 40 feet high. The building is not an architectural statement, it is a financial instrument. And financial instruments are shaped by what investors expect to get back. Here is how American stadium financing actually works. A franchise owner of products, private equity needs to justify a multi-billion-dollar construction cost. That justification comes from projected revenue streams, naming rights, luxury suite leases, premium seating contracts, concession agreements, and parking fees. Every one of those revenue streams has a physical implication for the building. Naming rights require a prominent, legible exterior surface. Luxury suites require sight lines and private access corridors. Premium seating requires separation from general admission. The architecture is not designed and then financed. It is financed and then designed around the financing. Now, here is what makes this incredibly important to understand. When a parametric lotus petal roof is proposed, the first question in an American boardroom is not, can we build it? It is, what does it add to naming rights revenue? And the answer is usually, nothing measurable. So it gets cut. Not because it is impossible, because it is financially invisible. China's state investment model asks a completely different question. The question is not, what does this building return annually? The question is, what does this building do for the region, for the city, for the national narrative, and for the civilizational story China is telling the world? Those are not financial metrics. They are political and cultural ones, and they produce completely different architecture. The Greater Bay Area Sports Center was not built to generate EBITDA. It was built as a civic gift. The Dalian Suoyuwan Stadium's free public rooftop ramp was not a revenue decision. It was a statement about what public infrastructure is for. The bird's nest was not engineered to satisfy a naming rights partner. It was engineered to make 1.9 billion people feel something. Most people never think about this. They assume the gap between Chinese and American stadiums is technical. But the technical gap is downstream of the financial gap, and the financial gap is downstream of the values gap. America decided, gradually and then completely, that public infrastructure should justify itself through private returns. China decided that infrastructure is how a civilization expresses what it believes about itself. One model produces 42,000 tons of interwoven earthquake-resistant steel shaped into something that makes 91,000 people feel the weight of human ambition. The other model produces a concrete bowl with a sponsor's name on it. Both are rational outcomes. Both are exactly what their systems were designed to produce. But only one of them will be remembered in 100 years as a building that mattered. And even that is not the deepest layer of the problem. Because even if you fixed the financing model tomorrow, you would immediately hit a wall that took China 2 decades to build through and that America has barely started climbing. The workforce that does not exist. Imagine you want to build a roof that runs on magnetic levitation tracks. You have the design, you have the funding, you have the approvals. Now you need the people. not just engineers in an office. You need structural engineers who have worked on maglev systems, facade specialists who have installed ETFE panels at scale, parametric design technicians who can translate a computational model into physical fabrication instructions, steel fabricators who have bent and welded geometry that has never existed before. And you need enough of them in one place at one time to build something in 34 months. In China, that workforce exists. Here is the part nobody talks about. China has produced more structural engineers, facade specialists, parametric design technicians, and large-scale steel fabricators in the last decade alone than America has produced in its entire construction history combined. You heard that right. 1 decade of Chinese engineering education output exceeds America's entire historical total in these specific disciplines. The result is that a 1,200-worker crew assembling a magnetic levitation rooftop in 34 months is not a logistical miracle in China. It is a standard delivery expectation. The project manager has done something like it before. The fabricators have the jigs already built. The site supervisors know the sequencing because they learned it on the last job. Here is what most people get wrong about construction timelines. They think speed comes from working faster. It does not. Speed comes from parallelism, running multiple work streams simultaneously instead of sequentially. And parallelism requires enough skilled people across enough specializations that you can staff 10 things at once without pulling people off other things. China's state-owned construction enterprises can mobilize thousands of workers across simultaneous parallel work streams because they have the depth. America's fragmented private contracting model builds sequentially: foundation first, then structure, then facade, then fit out because the subcontractor ecosystem is too thin to run everything at once. Schedule a parametric facade installation, and you will wait months for the 3 specialist firms in the country who can do it, because all 3 are already committed elsewhere. This is not a critique of American workers. American construction workers are skilled, experienced, and capable. But the ecosystem around them, the training pipelines, the specialist fabrication industry, the deep bench of parametric and computational design expertise was never built at the scale China deliberately created over 2 decades of infrastructure-led growth. The Chengdu Fenghuangshan Stadium's 77,000 programmable aluminum panels did not get installed by generalists following a manual. They were installed by specialists who had done comparable work before, supervised by engineers who understood the computational logic behind every panel's individual geometry. That ecosystem took 20 years to build. America does not have it, and the timeline to build it, if the decision were made today, is measured in decades. But the workforce problem, as deep as it runs, is still not the final wall. Because even if you had every specialist you needed standing ready, you would still face a barrier so embedded in American legal culture that most architects have stopped fighting it entirely: the liability wall. Think about what happens when an architect in America proposes something that has never been built before. Not something dangerous, not something reckless, just something new. A structural system that hasn't been used in this configuration. A facade material that doesn't have existing building code coverage. A roof mechanism that operates on a principle the insurance underwriters have never assessed. The response is not excitement. The response is a question. And the question is not, can we figure this out? The question is, who is liable if it fails? Here is the detail that puts everything into perspective. In the American construction and legal system, novelty is risk, and risk requires insurance, and insurance requires precedent. If a structural system has been used before and failed, the liability chain is understood: designer, engineer, contractor, material supplier, each with defined exposure. But if a structural system has never been used before, the liability chain is undefined. And undefined liability, in America's litigation culture, is uninsurable. And uninsurable means unbuildable. This is why the bird's nest could not have been built in America. Not because American engineers couldn't design it. Arup, the firm that engineered it, is a global practice with major American offices. The computational structural analysis techniques used were available to any firm in the world by 2008. The steel fabrication, while extraordinary, was not beyond American industrial capability. What was beyond American capability was getting the liability structure approved. 42,000 tons of interwoven steel, where structure and facade are a single inseparable system. No separation between load-bearing elements, and decorative ones means no clean line of liability if something goes wrong. American insurance underwriters would not touch it. Full stop. The Chengdu maglev-roof presents the same problem from a different angle. Magnetic levitation technology has existing liability frameworks in transportation infrastructure, but in a building? In a retractable stadium roof? There is no precedent. There is no established failure mode analysis. There is no insurer in America who has the actuarial data to price that risk. So the premium would be either prohibitive or simply unavailable. And without insurance, no lender finances the project. And without financing, the maglev roof becomes an exposed steel truss with a motor on it. Here is the brutal catch. This is not a failure of courage or imagination. American architects constantly propose extraordinary things. The problem is structural. Every novel idea that enters the American construction pipeline passes through a liability filter that was designed over decades of litigation to eliminate uncertainty. And architectural ambition is, by definition, uncertainty made physical. China's engineering approval process for novel structural systems moves at the speed of construction, not the speed of litigation. When the Hangzhou Lotus Petal roof required a new structural analysis framework, the approval body worked alongside the engineers to develop it in real time. In America, that process would require independent certification, years of review, and legal sign-off from parties who have every financial incentive to say no. The buildings China is building are not just architecturally bolder, they are legally impossible in America. And that distinction matters more than any engineering comparison, because it means the gap is not closable by hiring better architects or spending more money. It is closable only by changing the system, and that is a conversation America has barely begun to have. What the stadiums really mean. Here is what makes this bigger than architecture. China's stadiums are not the story. They are the symptom. They are the most beautiful, most visible, most emotionally immediate surface of a difference that runs through every layer of both civilizations simultaneously. The same gap that produced the bird's nest produced China's high-speed rail network. The same gap that produced the Chengdu maglev roof produced a train station built inside a mountain range and a canal engineered through terrain that every Western expert said was physically impossible. The stadiums are just the version of the story you can feel in your chest. Because that is what buildings do that spreadsheets cannot. They make abstract systemic differences visceral. You can argue about regulatory frameworks and liability law and state investment models for hours without feeling anything. But stand inside 42,000 tons of interwoven earthquake-resistant steel with 91,000 people around you, and the argument is over. You feel the difference between a system built to maintain what exists and a system built to create what has never existed. You feel it before you can explain it. Now here is the part that should stay with you. America is not losing this gap because it lacks money. The $5.5 billion spent on SoFi Stadium alone could have built something extraordinary. America is not losing it because it lacks engineers. Arup has offices in New York and San Francisco. America is not losing it because it lacks ambition. The architects proposing these ideas are some of the most talented people alive. America is losing it because it built a system gradually, legally, financially, culturally, that is optimized for the protection of what already exists. Every approval layer protects existing interests. Every liability framework protects existing precedent. Every private financing model protects existing revenue logic. The system works exactly as designed. It just wasn't designed to build cathedrals. China built a system designed to build what has never existed before, and the world is now watching what that produces. Not just in stadiums, in railways, in ports, in energy infrastructure, in the skylines of cities that did not exist 20 years ago. The stadiums are the part you can visit, the part you can photograph, the part that makes the gap undeniable. And you cannot unsee it once you have looked directly at it.